Hi my dear friends, welcome back to our YouTube channel. This is your ADC Max. How are you? I hope everyone is fine in your end. Please kindly take care of your health. This is one of the very interesting problem under the non-zero initial velocity one-dimensional wave equation. See the question is, usually we can see the stanza type, the paragraph type questions. Now the question is something mathematical expressions. Solve dou squared y by dou t squared is equal to a squared into dou squared by dou x squared. So what is this? This is the one-dimensional wave equation. Subject to the conditions y of 0 comma t equal to 0, y of l comma t equal to 0, y of x comma 0 is equal to 0. What's the mean there? The string is fixed at these 2 points, x equal to 0 and x equal to l. So at these 2 points there is no displacement, as we already know, isn't it? A third one, this is the displacement at the time t equal to 0. So initial displacement is 0. And what about the velocity? Velocity is given now, lambda into Lx minus x squared. So when we allow the string to vibrate with giving some initial velocity, then what will be the required displacement function? As we already know that the correct solution is y of x comma t is equal to a cos px plus b sin px into c cos pat plus d sin p. Isn't it right? So when we apply the first boundary condition at the x equal to 0, the displacement is 0, so we get a equal to 0. At x equal to n, once again the displacement is 0, we get p is equal to n pi by l. By using the third boundary condition at the time t equal to 0, we get c equal to 0. So by combining the arbitrary constants b and d as taken as cn and p equal to n pi by l, so we get the most general solution. So the fourth boundary condition is dou y by dou t. It indicates that there is a velocity, the rate of change of displacement with respect to time t. So differentiate this with respect to t partially. We get cn sin pi, so constant term, sin n pi at by l is cos n pi at by l into n pi a by l. Now using the fourth boundary condition, time t equal to 0, we get it is lambda into Lx minus x squared. The left hand side is sin n pi x by l, so this looks like the half-plane sine series. When you apply the half-plane sine series technique, we get Cn is equal to Bn into L by N by A. This is my hash. So please kindly watch my previous videos, problem number 1, 2 and 3 in the non-zero initial velocity time. Okay. Now I need the small bn value, because once we get the bn value, then we can get the cn value. So what's the formula for bn? Bn is equal to 2 by l integral 0 to l f of x sin n pi x by dx. Here the f of x is lambda into Lx minus x squared. Now by applying the Bernoulli formula, u v dx. So u v1 minus u dash v2 plus u double dash v3. When I substitute x equal to 0, x equal to l, we get 0. When I substitute x equal to l, sin by 0, sin 0, 0. So these two terms are become 0. So this is the last one. So minus 2 l cube by n cube into cos n pi x by l. If I substitute x is equal to l here, cos n pi value is minus 1 whole power n. By putting x equal to 0, cos 0 is 1. So once the two terms looks like this, when we decide if n is odd or even, so if n is odd, this becomes minus 1 minus minus 2, this becomes plus 4 l cube by l cube by 3. Is right? If n is odd. I think so. This is minus 2. So minus 2 to minus, this is 2 lambda by l is there already. So this 2 lambda by l. So this is nothing but minus 4 lambda l square after cancellation of 1 l square by n cube pi cube of minus 1 whole power n minus 1. Now can I substitute n equal to minus 1? I am reading now minus 1 is minus 2, it is plus 8. So 8 lambda l squared by n cube pi cube. If n is odd, if n is even, it is 0. If n is even, it is 0. So bn value is 8 lambda l squared by n cube pi cube. Now use this bn value in the hash equation. So we get cn is equal to 8 lambda L cube, because L is then the numerator, by n pi a. So we multiply one more n, we get n power 4, pi power 4 a. If n is odd, 1, 3, 5. What about for the infinity? It is for the even 0. Now, once we found the Cn value, use this in the MCS. So, using Cn value in the star equation, using the Cn value in the most general solution, star equation, we get the required displacement function y of x comma t is equal to sigma. Now, the Cn value is non-zero only for n equal to odd. So, it is 8 lambda L cube by n power 4 pi power 4 into a into sin n pi x by L, sin n pi at by L, sin n pi x by L into sin n pi at by L. So this is the required displacement function of the string under the non-zero initial velocity, under the non-zero initial velocity. So this is the fourth problem under the non-zero initial velocity in one-dimensional wave equation. Thank you. Thank you so much for watching our YouTube channel. This is signing off, your ADC. Please kindly subscribe and support our YouTube channel ADC Max. Thank you.